Okay, so these are some common symbols, flowchart symbols, and you've seen this before, right? These flowcharts, circles and arrows, and the parallelogram, and rectangle. Remember your geometry, and then the diamond shape. Okay, so in this class, this chapter deals with that diamond shape at the bottom there. That is the conditional shape that will make decisions, right? Either yes or no. There's no other branches out of that diamond shape. So one coming in and then two going out. Okay, that's it. There's no less and there's no more than that either. So that is the diamond shape. And this, again, this is not a complete list of the flowchart, but the most common ones you'll see in any diagram. The oval always starts the program, it ends the program. Flowchart, the flow line is how and where data flows. So you follow the lines, the arrows, and data flows that direction. The parallelogram is used for printing out and reading data. So you use that same shape. When you see that in your flowchart, it's always about printing or output and input. And so usually you use this to guide your code. Okay, when you write, you can use pseudocode to write out what the program should do, or you can use flowchart, or both. Okay, sometimes you put pseudocode inside these shapes to help you. And once you study these diagrams, you can kind of have a pretty good idea how to code and where to start and begin and so forth. So really, really helpful. The rectangle is for processing. Right? Remember I mentioned about three things in programming is the input, processing, output, right? So input is the parallelogram, processing is the rectangle, output is back to the parallelogram. So it's usually used for that, and it should use only for that purpose. Okay, which is why it's a standard to use these in the programming industry. And then, so these are the relational operators. Some of these were from chapter 2. So you should know these by now. These are only the only relational operators in Java. Okay, if you go into JavaScript, you have more. You actually have a couple more. You have the 3 equals instead of the 2. You have the 3, and then you have the 2 equals with the greater than, and 2 equals with the less than as well, and then down here as well. So you have like a additional set from here to the bottom of this list, because of that extra equal sign. And that just means in JavaScript means you have to have the same value and also the same data type. Okay, so in Java it doesn't do that. Okay. Then the if statements here, I put here the notes, just different syntax when you use and when you not use the else statements, right? So you can just be a if block like this. If something is true, then run this and then done. Okay? Or you could also just do this without the curly brace at all. If this statement is a single statement. Notice again I put a single statement here versus over there going to put it one or more with the plural. Right? So if you have more than 2 statements, you have to wrap it with the curly braces. Otherwise, if you don't, then the next statement will be ignored by the if block. Okay, so we'll do some example of those. So here's that famous diagram. You see this everywhere. It's usually like this. So the input coming into the diamond shape. It doesn't matter how you draw this. Okay, this is just not. It's just logical this way because we see things this way. You can come any direction, okay, to one of those corners. So in this example is you have a data flow. So the arrow is the flow data coming from the north, right? Enters that diamond shape, and then in here you have a condition to test. The condition here is coded in here in the if block, as you can see at the top here. Okay, so the code on the top and then the diagram on the bottom to show you how things are laid out and how they're related. And so if you see this diagram, then you know that your code will look something like above. Okay, so you would test for the quiz score if it's equal to 10, exactly 10, right? If that is true, then we will branch out to the true side. Again, you follow the arrows. If it's not equal to 10, then you follow the false side, the arrow. And then in this case, if it's true, then we're going to print out. So the parallelogram means to output, right? Or input. In this case, output. We output the message to the screen, and that's all it does. And then you follow the arrow. Again, it goes out of the box and then down to the next block of code, if there's any. If it's not, it will end there. If on the false side, as you can see, there's nothing there to be done. You just basically exit out of that loop, that block, and you move on to the next one. Okay, so this is a typical if block. Okay. So learn about the else block. The else here has both the true and the false. And what the else means, you have to print something. In addition to the truth part, you have the false part as well. So this one up here, we didn't really care about the false part. If it's true, then we print something. If it's false, we ignore everything. But this one down here, we need to take care of both of those sides. So that's why you have statements both in the true part, this is the true part, and then this is in the false parts. Okay? And so you can have two branches. And the code looks like similar as before, except we add another box here because we need to output some data on the false side. Okay, so that's the if and else block. Without one or the other, then it would just be the if block. Okay. Then the next one here is called the nested if-else statements. That means you can have other if statements inside other if statements. Okay? You can nest these together and you can go as deep as you want. It doesn't matter how deep you go. But it does get really confusing if you go deep into these nesting paradigm here. You can so you can check for if the first part is true, then you can go into the true part and you can do another test. If this is also true, then you will display something or process something or branch out to another application, right? So you can do that.
Can you do that as many times as you need?
You do as many times as you need, however you need it. There's no limit, there's no rule. So you can if you, yeah. Yeah, because you can, but it does get a little confusing if you have a lot. So you have to be really careful because it's either 0 or 1. There's no other option. Yeah, well, that is the way to do it, right? So you break it out to functional, break it into smaller parts because you have a lot of nested if statements. It's really, it can get complicated. Okay, or you can combine these together because this is true and this you can combine with the and. We'll learn about that later. Okay, so the if and else if statement. Okay, so you see that else if. So you can see the previous one didn't have the if block here. It just say if it's true, else do this. Now you have else if. It's like a continuation from the previous one, but now you put an if block here because you test the second condition. Now the previous one up here, the if and else, we did not test the second part. We only test the first part. There's one condition. If it's true, then you go in here. Otherwise, it cannot be true. So we know for sure it's not true. So we just say else and then run that, right? That's it. Now, this one, we are testing the first condition. If this is true, then run this. Else, if it's not true, if it's something else, then we run that. And then if it's not true either, then in this case, we just ignore the rest. Okay? So an example would be something like, if you are a student, if that is true, then yes. If it's not true, then if you are a faculty, right, then yes or no. If it's yes, then go in here. Otherwise, if none of the above, then you exit out. Okay, so you test each layer, each individual case in that direction. Because let's say maybe you cannot be both. If you are a person that holds 2 or 3 different types of titles or jobs, then this may not apply to you because you're both, right? This one only applies to one case. So, and you can have again as many block as you want. Else if until you find the truth one. If there's none, then you can just show an error or a message saying it's none of the above. Okay. And notice that this one does not have the else at the end, because the last part, if none of the above is true, then we just don't do anything about it, right? If you care about a default state or default type, then you will put the else block at the end, and it's always the catch-all statement. If none of the above is true, then the else part will always take it, right? So if that's important, then you put it at the bottom. Otherwise, just again exclude it. Okay, so again, the nested if statements, you can have as many as you want. Again, this is the first condition, the outer if. Okay, you hear this term a lot, the outer if, the inner if, and then they have inner if, right? Keeps going, but so usually the outer if here. Just make sure you put the curly braces in the right spot, and make sure you cover them, because if there's a typo somewhere, and that's why it can be really tricky if you have a lot of nested ifs blocks in addition to other blocks. So you can have here, and then you have statements before, after, another nested block inside here, and then inside here you can have more nested if you want. So it can go as can be complicated. So here I have 2, here I have 3 conditions. Okay, and then the else part also have something similar. So again, you just follow the flow of data, the arrows, follow the arrows, and then it will help you to do your code. And then the logical AND, and logical OR, and the operator and the NOT operators. Again, I'm just going to talk over this really quick. We'll do the examples. These also are called short circuit operators. Okay, you know what short circuit means? If you're in the electronics field, right? If you make circuits, what? Yeah. Mm-hmm. Yeah. Mm-hmm. Right. Yeah. So you have a strings of things, right? Events, and if one of those is failed, then the whole thing gets is short-circuited, right? So that's exactly what it is. So these are called short-circuit operators, and the reason why they are short-circuit operator is because of like this case here. Okay, so I'm having up here this block of code, and this one here is exactly the same. Okay, I mentioned earlier that you can combine them together. You can combine these conditions together, and you will create something called a compound condition. Okay, this is compound condition because this is has 2 or more, right? So one condition here in the front. This is the other condition, and you would combine those together, and in between you will use either the AND or the OR, which is the 2 pipes symbol. Okay, and this have to you have to kind of be familiar with the truth table, right? If you've seen before, I'm sure you have. So true is always true, and true false is always false, right? And false is false, things like that. Okay, so you combine 2 together like this. So in order for this statement, this whole block, right, to be true, both of those conditions have to be true, right? So that means I'm going to test the first block first condition. If n is n1 is larger than n2, if that is true, so you got a T for that, then I need to check the second part as well. If this is also true, then the whole thing is results into a true statement, true condition. So that block will execute. Okay. If this is true, but this is false, let's just say n1 is less than 0, then the whole thing is false. Okay. So the reason why we have the short circuit is this, because in here, short circuit means if it's an AND operator, and means both have to be true. So if this is true, then I need to check the second one is also true or not, right? You need to know, otherwise you can't tell. But if the first part is already false, right, then the second part I can completely ignore it, because it's going to be false anyway. If there's one false, the whole thing is false. So when you use this operator, that means if the first condition is false, then the rest, doesn't matter how many you have, the programmer will ignore it. I mean, the Java will ignore all of the rest. So that you don't have to spend extra CPU time calculating all those conditions. Okay, so it's an issue. So again, the term short circuit. Okay. So if it's true, then you can run the second one. If it's false, then you can ignore the rest. Okay, that's the short circuit. Now the OR operator is kind of the same thing, except OR is as long as one of these has a true condition, then the code will run. Right? It's OR. It's true, true, it's going to run. True, false, it's going to run. False, true, it's going to run. Either one. So that means you check the first one. If this is false, then since there's a second one, you have to check the second one to make sure that it's true or false, because you don't know. So you check that. If it's true, then it runs. If it's false, then the whole thing is skipped. Okay? But if the first case, if this is already true, then I don't care the rest. If it's true or false, it doesn't matter. It's already qualified. Right? So same thing. That means the rest can be ignored, and the compiler will not even try to, the computer won't even try to execute those. Okay? So again, that's short circuit. And save you a lot of CPU time. Okay? I think most languages have these operators, with the exception of Visual Basic. Visual Basic actually has both the short circuit and the non-short circuit operators, which consumes a lot of CPU time if you don't use it correctly. Okay, but most languages have just these two. So that's the OR, and then there's the where's the NOT? Okay, we'll talk about NOT later. And then there was a switch statement, and before we go to the switch, I'm going to stop here. We'll do the if block first. We'll come back here. There's the NOT, which I don't see here. I want to show. Oh, there it is. Yeah, the NOT operator. This is the other operator. The NOT means you reverse the result of the expression. If the result is true, then you reverse it to be false, and vice versa. And so it actually used as a verb in the programming world. You say not it, right? Not the expression. That means you reverse the result. So in this case, for example, you put the not in front of an expression because it will reverse it. You check this part first. If n is greater than 10, in this case it's not, because n is 20. It is 20, so it is true. So the result is true, but then I not it, so now it's false. Okay, so you reverse it. And so this is false, and therefore this will not execute. Okay? And then this is another way you can do this as well. A shortcut, you don't have to say, found equals true. You can, but this is a shortcut. It's a truthy or falsy variable. That means if you say found, then that always means true. You force it to be true. And then you put a not in front of it. That means make it is not true. So now it's false. Okay? So very handy, especially if you write a code or a game program to kind of like toggle between yes and no. Like when you fight something, you press the button on off, like a light switch. So you just put the knot in front, and that will always create you a toggle button or option. Okay, it's very it's tricky, but it's very handy. And we'll come back to this operator later. This is the conditional or the ternary, or sometimes called the Elvis operator. Okay, Elvis, because if you look at that, the question mark and the two eyeballs, if you rotate it upside the other way, you look, it's like Elvis, right? The hair and then the shades. So we call that the Elvis symbol. So I don't know how you got into programming, but there it is. Okay, so let's go into the code and do some exercises in here.